For the solutions, some I will give more explanation than others. Make sure that if you haven't already, go through and try them once on your own first without looking at the solutions. It is important. That's the only way that you're going to actually learn from this. And then that way you'll be prepared for tomorrow. So for the recursive definition, I'm defining the nth term in terms of the term that comes before it. So the nth term is going to be the term that comes before it minus 2. And of course this will start, n must be greater than 1. It will start with the second term, right? I can't use that for the first term because I need a term before it. So I have to tell you what the first term is. A sub 1 is 5, and then working with n greater than 2, I can start with n equals 2, and that will allow me to use the recursive definition. For the closed formula, what I want to do is say, okay, look, I'm starting with 5, and each step of the way I'm subtracting another negative, or I'm sorry, subtracting 2 each step of the way. And so the question is, how many 2's am I subtracting? Well, the first term, when n is 1, I don't want to subtract any 2's from 5. Right? So I want to have n minus 1 be the number of 2's I'm subtracting, because when n is 1, I don't want to have any of them. But when n is 2, I'd like to subtract one of them. So obviously when n is 2, think about it, 2 minus 1, then I will have exactly 1 2 being subtracted, and that will give me exactly what I'm looking for. And of course, this will work for n greater than or equal to 1, because I can use this now to find the first term. Here the pattern is that I'm multiplying by negative 1/2, or another way you can think about it is dividing by negative 2 each time. So 25 divided by 2 would be 12.5, but it's negative, so I divide by a negative. It's easier to think about multiplying by the common ratio, because that allows us to think about our formulas in a little more of an easy to manage way. So what I want to think about is that each step of the way I'm going to be multiplying by negative 1/2. Recursive definition, pretty straightforward. I'm not actually going to really go over that one. And make sure to define that n must be greater than 0. Closed form definition, similarly, any term, a sub n, can be found by taking the original term, or sorry, the initial term, 25, and multiplying it by a certain number of negative 1/2. So negative 1/2 to the n, thinking about when n is 0, right? I don't want to be multiplying by any negative 1/2. So the 0 exponent will make this 1, and that will allow me to get just 25. So this is for n greater than or equal to 0. The value of the sum of the 5th through 12th term. So what I want to think about here is that this is taking the terms 5, 6, 7, 8, 9, 10, 11, 12, and adding them all up. How am I going to figure that out? Well, if you think about it, what I'm doing is I'm taking the first 12 terms and I'm subtracting away the 0th term, the first term, second term, third term, fourth term. Now there's a little typo here. This shouldn't be all the way up to the 5th term. I should be subtracting away up to the 4th term, because I want to keep the 5th term in my sum that I'm looking for, right? This here is going to be a sub 5 plus everything up until a sub 12. And so I don't want to subtract away the 5th term. So this should be s sub 4. And when I do that, I get a slightly different answer here. So you might have been tempted to get negative 0.5, but what you should actually be getting is 1.04 approximately. And this should make sense because the first term is 25, and everything from there on out is going to get smaller in magnitude. So eventually I should be getting smaller and smaller terms. So the 5th through 12th terms are going to be pretty small, and so they should sum up to something that's fairly small. Right, recursive definition, pretty straightforward here. This is the closed form function, so I can find the initial term, which is when n is greater than or equal to 0. So it's equal to 0, and so that's going to be f of 0, which is 10. All right, that's the term that I'm starting out with, and that's 10 times 2 to the 0. 2 to the 0 is 1. And then so then the recursive definition says, okay, you want the nth term, well, take the one before it, multiply it by 2, right? The common ratio is 2, and that works for any term after the first one, or after the 0th term. So starting with 1. And I want to find the sum of the first 10 terms here. So what I'm going to do is I'm going to take S sub 10 and explain why your answer makes sense. And I get 10,230, and that should make sense because I'm starting with 10, and every time I'm doubling it. So each term is going to get twice as big as the previous one, and I'm adding them all up. So I should be getting a pretty big number. Again, pretty straightforward here. This is an arithmetic sequence. I'm adding 3 to each successive term, and the initial term is -4. Got to be careful here and note that n is going to start at 0. So when I'm doing the closed form function, here what I'm thinking about, instead of n minus 1 here, it's actually going to be starting with, it's just going to be n. So I'm going to be adding n number of 3's. Right, so if I'm starting at the 0th term, I don't want to add any 3's, so it's just going to be 3 times 0. And that works, of course, for n greater than or equal to 0. Just deriving the formula for the partial sum of a geometric series. And the sequence, right, a sub 1, a sub 2, all the way up to a sub n, we want to know how do we find a formula for adding these all up without having to add them all up. So what I want to do is I want to say, how can I write a plus 1 plus, or a sub 1 plus a sub 2 all the way up to a sub n in a different way? The first thing that I've got to remember is, what is each of these terms? How do I figure them out? Well, I start with a sub 1 and I multiply by the common ratio a certain number of times. So the second term will be the first term times r. The third term will be a sub 1 times r again, or r squared. And the nth term will be a sub 1 times r to the n minus 1. And then what I do is I multiply by a form of 1, right? R minus 1 over r minus 1. And on top, the numerator, -1 times a sub 1 is negative a sub 1. Then r times a sub 1 is a sub 1 times r. And then -1 times a sub 1 times r is negative a sub 1 times r. So these cancel. And you can work it all the way through and show that everything will cancel up until, and you should do this, I'm leaving this out because we've already done this, but you should work it all the way through so that you can explain how I will end up with the last term, which comes from a sub 1 to the r minus 1 times r, which will just be a sub 1 times r to the n. And if you can't understand this, this is definitely a good question to ask tomorrow. So what I am left with is just going to be a sub 1 r to the n minus a sub 1 all over r minus 1. So s sub n is equal to a sub 1 r to the n minus a sub 1 all over r minus 1. And I can factor out an a sub 1 in the numerator, and so the final formula that I arrive at is that the partial sum of a geometric series s sub n is equal to a sub 1 times r to the n minus 1 divided by r minus 1. Alright, so here for part A, a certain number of years have gone by and then your account has $150. How much will it have 2 years after? Well, you know that the investment account gains 12% each year. So each year you're going to multiply by 1.12. Obviously the 1 making sure that you're retaining the money in there, and the 0.12 adding the 12%. So you have 150, you multiply by 1.12, that's 1 year, and then multiply by another 1.12, and that will give you after the second year, and that's approximately $188.16. Part B is a little more confusing. You are told how much you have in the 8th year, and you want to work backwards to figure out how much you started with. Well, this is where you can use either the recursive or the closed form definition. You could start with the 8th year and figure out the 7th year, and then you could use the 7th year to figure out the 6th year, so on and so forth, but that would take you a while. Or you could realize that you're multiplying by 1.12 each time. So the nth term, the nth year is going to be the year you started with, the very first amount that you put in there, 0 years in, multiplied by 1.12 times the number of, or raised to the number of years. And you can think of this, right? This is the amount you put in, and then when n is 1, that'll be 1 year, so you'll multiply by 1.12, and that will give you your amount after 1 year. Now, n will be 8 here. I want to find the 8th term, right? I know the 8th term, which is 2000. I now have an n value of 8, and I can use that to solve for the initial value. And going through this, 1.12 to the 8th is approximately 2.48 multiplied by a sub 0 equals 2000. And then I'm going to divide on both sides to get that a sub 0 is $807 about. And this should make sense because I should have less than 2000. So if you get some huge number like 8 million, clearly your value is incorrect. Alright, so here I'm not going to give you the full answer. I'm going to give you a hint. And the hint is this. You are saving $500 per year and adding that to your account. So I want you to think, or the way to think about this, there's a couple actually different ways to think about it, but one way is to consider each 500 that you put in the bank separately and then add them all together. So the first 500 you put in will be in there for all 20 years. And so you can find the value of that 500 after 20 years by thinking about how many times it will be multiplied by 1.04, right, the interest. Then the next year you're going to add another 500, and that's going to stay in for 19 years. And so you can think about how much that 500 will be worth by compounding the interest 19 times. So 500 times 1.04 to the 19th. And you can go on all the way down the road, and that will give you a bunch of different terms which you can then add up to give you how much money you'll have after 20 years. Part B is a little different. You want to retire at age 60, so that takes into account your current age right now and then how much longer it'll take you to get to age 60. And at that point you want to have $2 million. So you want to use this $2 million to think about, okay, what do I want to start with? So go back to Part A and use what you did in Part A to help you set up an equation to solve Part B. I will put up the answers to this and a little more detail tomorrow, but I really want you to give it a try here because this can be a confusing problem, and you will only understand it if you give it a little bit of effort first.